This unit is all about functions, and we haven't really dealt with functions yet, per se, but we actually have been dealing with equations of lines and whatnot. Those can be functions. Functions are like a special type of um, equation, okay? So this section to begin with is going to be relations and functions. Before we actually get into functions, we need to first talk about um, relations. A relation is a set of ordered pairs, so like a point, and we know that an ordered pair is always x comma y. I'm not gonna have you write that down just because I think that one's obvious. And then we have a domain and we have a range. Some of you may have already dealt with this, some of you may not. Our domain, these are all of our x values. Our range are our y values. And the reason why this is the way that it is because we know an ordered pair is x comma y. So the domain is what I plug in. The range or my y is what I get after I plug it in. Okay. This is sometimes called your input for domain. Your range is sometimes called your output. Now, let's talk about what a function is. A function is a relation that assigns each domain number to exactly one range number. Okay, so we're going to look at some domains and ranges, and we're going to compare them to see whether or not they're actually a function or not. So when I'm first looking at this, you're going to have a table of domain and ranges. So let's say my domain, I have -2, -1, 0, 1, and 2. For my ranges, I have -6, -4, 3, 5, and 6. All right, so they'll list out your domain and your ranges. Again, this is all just this will be given to you, so you don't have to worry about that. Okay, so looking at this, we've got some arrows here. This is what we call a mapping. And we're trying to figure out, okay, is this a function? So if I'm trying to figure out if this is a function, I look at the domain values and figure out how many arrows are going away from it. If the domain number has one arrow leaving it, then it is a function. So, okay, I'm looking at that criteria. My domain, -2, has one arrow going away from it. -1 has one arrow. 0 has one arrow. 1 has one arrow. 2 has one arrow. So in this case, this is a function. All right, so let's look at one that is not a function. All right, so looking at this one, this -1 has 2 arrows coming from it. So this is what makes it not a function. The 0 has 1 arrow, the 1 has 1 arrow, and the 2 has 1 arrow. Okay, so the -1 has 2 arrows, so we know right now, no, it is not a function. Now, some of you may be asking, well, what about the 4 for the range? It has 2 arrows coming to it. That is perfectly fine. We're worried about the domain, if the domain has 2 arrows coming from it. Okay? So for you guys, I'm going to ask you a question on whether or not it's a function, and you'll answer your question. So looking at this, is this in fact a function? All right, so when I'm looking at this, I'm looking only at the domain. Do they have 1 arrow coming from it? So looking at the 6, 10, the 12, and the 18. Yes, in fact, they do only have 1 arrow. It is a function. Now, in the other thing, we talked about input and outputs, and there's some special notation for it. What we know about a function is it's got special notation. So for instance, I have y equals 3x plus 1. Okay, so that's a line, we know that. If I were to write this in function notation, it'd be f of x equals 3x plus 1. The reason why is because we're limiting this. That equation y equals 3x plus 1 might not meet the domain and range criteria. So that's why it's a function. Okay, so that's why we split it up. The y basically is the same thing as f of x. Well, what is f of, let's say we're working with the same one, what does f of 2 equal? So what that means, the 2 gets plugged into the x spot. And then you solve it on the right side. So we know that 3 times 2 is 6 plus 1 is 7. All right. So for you guys, your function is negative 2x minus 3. And I want you to find f of negative 1. All right, so f of negative 1, I'm going to plug that right into my x spot. And then I'm just going to solve on the right side. So negative 2 times negative 1 is a positive 2. 2 minus 3 gives me negative 1 as my final answer.